So in a previous video, I showed you how to wire up these circuits, and we gave them different names based on how they performed. The AND gate needed both switch A and switch B to be depressed for the output to turn on. And because of how the OR gate is arranged, switch A or switch B had to be depressed for the output to turn on. Now if you think about this is a very simple form of logic. We've somehow tricked electricity to think, because logic is just making a conclusion based on information. So the output here would be the conclusion, and whether or not the switches are pressed is the information. So let's simplify this a bit. Since we're going to draw these circuits a lot, let's assign them different symbols. This would be the buffer circuit, or what we call the button circuit. And this is not 5 volts, it's the input to the switch. So we'll label it as input, and this is the output. For the AND gate, we'll have 2 inputs this time because we have 2 switches. Then we draw sort of a D. Then the output, we want to label switch A and switch B. Then for the OR gate, we also have 2 inputs. Then we have this crescent shape at the front of the OR gate. Then the output. Now remember, we also made the inverted circuits. With the inverted circuits, the outputs were connected directly to 5 volts, but then the switches would have the capability to short that output. So this would be the opposite of the button circuit. So what we do for the opposites is we just add a bubble to the front of the normal circuit. So this would be the inverted button circuit, or the NOT gate. This being the input and this being the output. We can do the same for the other gates. So this is the NOT AND, or the NAND gate. Same concept as the NOT gate, where you have an AND gate and the output connected directly to 5 volts and giving the switches the opportunity to ground the output. And again with the NOR gate. And they of course have their own symbols. Just looks like an AND gate, but instead it has a little bubble at the front. That is the NAND gate, with this being the output. The same for the NOR gate. Okay, so now we have 6 logic gates. What we call the buffer circuit and its opposite, which is the NOT gate. What we call the AND circuit, and its inverse, what we call the NAND circuit. And then the OR circuit, with its inverse being the NOR circuit. And that's all you need to know regarding logic gates. It doesn't get any more complex from here.